Hey guys, maybe a little history of Avere. We've been around for 7 years. I've been with the company 6 years, and we've actually developed a caching technology to accelerate network-attached storage. If you've seen any movies in the last 4 or 5 years, and some of the customers are here, we've had something to do with it. We've accelerated the NAS access from the render nodes or transcode engines or even the artist. So we've had a bare metal machine for a long time, and just recently, over the last 8 months, we've developed a virtual machine, and we're pretty excited to have Google part of that now. And over the last year as well, we've developed a connector into any type of object storage device. So we're using the S3 API to connect into any type of either Clever Safe Lamp data or any software-defined storage. So we're pretty excited to have Google part of that today. Okay. So the two offerings we have with Google, and again with we're not new to virtual machines at all. We've actually been using virtual machines for a number of years. Our QA and engineering team use our own virtual machines running in VMware, as a matter of fact, to do any engineering and QA. So it keeps the cost down for building out hardware to do that. This Google offering is pretty cool because we can the storage that you can use is just infinitely expandable, and the compute engines that you would use for rendering is you can span that out to whatever you want. So what we do is we offer up a file system we're a proxy to a file system, either from an object storage device or some other type of NAS type of device. So we offer up NFS and CIFS to the clients, and it could be artists, it could be render nodes, it could be transcode engines, and then in turn we talk NFS and the S3 API back to the storage device. Some of the target industries are media, entertainment, life sciences, and financial services. Like I said, we've been around for a long time. We have a number of hundreds of customers out there. The early adopters were media and entertainment, so I think that's why this is going to be pretty interesting, this offering from Google. So what I'm going to do, I'm going to kind of talk about configuration here. And if there's any questions, if I don't cover something, please ask me later on. So down on the initially, like I said, we had a bare metal appliance. The bare metal appliance was installed on-prem, of course, and the reason for that is to offload that NAS product, whatever type of those legacy NAS vendors you have, from the IOPS that these render nodes were beating the living out of the storage. So we're offloading all that stuff. What I mean is that we're putting the active data set into our tier. We're a caching appliance. We're a proxy of the file system. We have multiple different mediums inside of our devices. We have DRAM for fast access. We have NVRAM for writes, and we have SSDs and SAS drives. So we move data back and forth between these different mediums depending on the active data set and how what the needs are from the render nodes and whatever other clients. So on the bottom half of this slide, you'll have your on-prem storage. You have your render farm as well as your artists, and on the right of that you have the NAS and object storage device. Not necessarily say that you would have an object storage device, but that's something we think will be pretty impressive going forward, because the NAS vendor's cost is getting kind of over the top. On the top, we have the Google Compute Engine. So if we talked about burst computing a little earlier on, and if you don't have enough hardware on-prem in order to finish the jobs that you have, it'd be great to be able to spin something up into Google Compute. In addition to that, you could use Google Storage as well. But the thing is that in order to do something, in order to really utilize the compute farm in Google, you have to be able to get the data up there. So what our devices, again, remember I mentioned it's a proxy. Well, what that means is if a request comes in, either the bare metal machine or the virtual image, and we don't have it, it's a cold cache hit, we're going to go back and get it from the storage. So on the bottom, if that was a bare metal machine, if the render nodes make a request for something, say it's a new job, a new render, a couple shots that you're rendering, we're going to go back to the NAS product and grab it and stick it in there. And we're going to keep it there forever until there's competition for space because, obviously the job's going to finish and something else is going to be more important. The same thing happens for the virtual machine. Okay, on the top left, we have the Google Compute. And what we've done is we've utilized our software to build a virtual machine cluster. We're a clustering solution. We have high availability, so you can build this cluster out to 50. I don't have a customer that has 50 in a cluster. I think the largest cluster I've seen is about 21, but that's not usually normal. But in any event, you can scale this cluster within Google Compute depending on how many IOPS you're trying to drive with your particular job. So that virtual cluster can also access the on-prem storage. So again, you don't have to copy data up into the cloud and leave it there. You can just fire off your job. We're going to go back to the on-prem storage and grab that data and shove it into our cache and keep it there. We're going to replicate that data amongst all those virtual nodes and serve it as, parallelizing it out to the render farm. All right. So when you're done with that, when you're done with the job and need to output that, you can write it back to the Google Cloud Storage, or you could write that back all the way down to on-prem. We offer a global namespace that I'm going to talk about in the next slide that kind of goes over, how we can kind of put this all together in one big globe, so to speak. So since we're a proxy of the file systems, we take either the NFS exports or those buckets from either Google Cloud Storage or your on-prem object storage device. We roll that into a file system. We're going to present that, even an object storage device, we're going to present that as NFS or SMB. Okay. In addition to that, what we can do is we can roll together a namespace around all of these different NAS products or object storage devices, as well as the Google Cloud Storage. And what I mean is that you'll be able to, you could potentially just mount / at the top of the hierarchy and just CD and change into your different type of the different directories or shares that we would have representing these different object storage, the buckets or also the on-prem storage. What's really interesting is that, global namespace is fun and everything, but I think what's really compelling is if you could do something really interesting with it, like move data behind the scenes. And the reason why we can do that is because we terminate the protocols, but we also offer up our own file system IDs. Again, we have to do that for object storage devices anyways, because there's no such thing as a file system ID. Just to comment on object storage device, what we do is these buckets that are being presented to us that we gather into our namespace. We look at those objects as actually blocks. So, depending on what object storage device is, it could be a 1 meg, it could be a 4 meg, actually block size. Since we treat the object storage device a little differently, we actually cache the data differently than we do a NAS product. We try to keep all the metadata for all those buckets that are active and even keep the first 16K of files. We also offer now, that just came out a couple of months ago, is we offer up a snapshot for your object storage device. So if you had either an on-prem Avere cluster, right, that you already have, and you're accessing the Google Cloud Storage, or you have an on-prem, or the Avere cluster within Google Compute, we could offer snapshots for that. So you could have versioning for that particular data that you're dumping out there. Since we offer up our FSIDs, that allows us to do something kind of, some gymnastics behind the scenes. And what I mean by that is that you're able to do a move or a mirror of data. And in this example, what we're doing is we're actually moving from your on-prem storage, whether it's object storage or some type of legacy NAS product, up into Google Cloud Storage. So we can do that without anybody really knowing. In other words, what I mean is that the clients won't know any different that something has moved because we offering up the FSIDs. So the FSIDs never change. So your clients are never going to see any type of stale NFS handle or anything like that. Here's an example of, we've seen this slide a little bit earlier. This is an example of actually one of our customers, and it's actually another. There's two. There's one in media entertainment. There's another customer that's not in media entertainment. What they have is multiple locations that are accessing either the Google Cloud Engine for rendering or some kind of compute of any kind, or also accessing the on-prem storage. And what's not shown here is that one of the things that we do is we eliminate the latency that your clients are seeing when they access that NAS storage or that object storage device. So since we eliminate the latency, we're a latency killer, as well as an offload engine. We can place these bare metal machines, at some other location. So in this instance, and there's people here in the crowd here that are using it for remote WAN caching. So you could have LA, Vancouver, and New York, and any other location that could have these Avere bare metal machines caching either for something that's stored in Google Cloud Storage or actually caching for your on-prem storage that would be at a different location. So most initially the customers bought the bare metal machines for just on-prem acceleration, and ever since then, after we came out with the feature of WAN caching, they're actually putting us at other locations. So what that means is you can have people in Vancouver working, which is happening, due to the tax incentives, or like Rodeo FX is in Quebec and Montreal and everywhere else, but the storage is living in some central location. So this is the product line. We have the Google Virtual FXT, and that has a certain size of DRAM and SSD, and then we have the hardware off to the right. And we have 3 models right now, and the farthest one on the right is the 4850. It's the highest performing model because it's full of SSDs. The kind of the flagship product is 3850, which has a mixture of SSD, DRAM, and SAS drives for the coldest data. What we do is, since we have these multiple different types of media, we actually move data, demote it, and promote data back and forth within those media types, depending on how what the client's needs are. So that in mind, we also have an NVRAM card in the bare metal machine. So some of the tests we've done with the Google with the virtual image that runs within Google Compute is that the speeds are really, really close to what the low-end bare metal machine that we have. The only thing that's different is the writes. It's because we don't have there isn't an NVRAM card in Google Compute yet, so we have to commit those writes to SSDs. But other than that, the reads are maybe 80-90% of what the bare metal machines are. So just to recap, the connector that we use to talk to the storage is NFS v3, or we use the S3 API, which is what we're using to talk to the Google Cloud Storage. We can scale the bare metal cluster or the virtual cluster up to 50. Not that you would do that, you would have to have 150,000 nodes or something to be able to spin a Avere cluster up to 50. And we have one of the other things that we probably should have had a slide on is the statistics. And somebody mentioned about statistics a little earlier on this morning. We have about 10,000 statistics that we can present. It's just dizzying, and the things that you can gather. And the reason why we can gather these statistics is we kind of we're in a data path, of course, but we have our head above water and below water, so to speak, right? Because we understand what the clients are doing, and we also understand what the back-end storage device, whether it's an object storage device or a NAS product. So we can tell you, what's happening with the core filers. We can tell you what the clients are doing, and more importantly, we can drill right down to tell you what the hot clients are at any particular point in time. We can tell you the rate of I/O and what that I/O is. We can drill down even deeper and tell you what the clients are doing. So we can give you a list of the hot clients, and we can tell you what type of activities they're doing. Are they doing reads? Are they doing writes? Are they doing directory updates? Okay, and we can tell you the path of the file to do that. And you can gather that through our dashboard, our UI, or you can actually use our API. We have an API based on XML RPC that you can use to gather all that data and put into any other tools that you might be using today.